This is the homework help video for the spring final review, and this is Unit 9, which is on logarithms. Okay, so the first thing we want to do is simplify. So we're trying to figure out what power on 3 is needed to get 1 over 81. So what power on 3 is needed to get 1 over 81. So I know 3 squared is 9, 3 cubed is 27, so 3 to the 4th would be 81. So 3 to the 4th is 81. And then it's a negative exponent because I want to get a fraction. So I know it needs to be negative 4. So 3 to the negative 4 would be 1 over 81. Okay. And then let's take a look at number 3. So what power on 2 is needed to get to square root of 2? So I know 2 is a power of 1, right? So that's just the same as 2 to the 1st. And then the square root of 2 is the same as 2 to the 1/2 power, right? So square root of 2 is to the 1/2 power. So 2 to the 1st, and then root 2 is 2 to the 1/2. And so then now I would add my exponent, so I would just do 1 plus 1/2, which is the same as 1 1/2 or 3/2. Okay. And let's take a look at number 6. So I have the natural log of 1. So to do the natural log of 1, I know this is an implied base of e because there's no subscript there and it's natural log. So what power on e is needed to get 1? So what power on e is needed to get 1? And so when I have a power of 0, that gives me 1. So then that's just equal to 0. And let's do one more, number 9. So an implied base here is 10 because it's just log, so subscript 10. So what power on 10 is needed to get 100? So 10 to what power gives me 100? And I would need a power of 2 because 10 squared is 100. Okay. And then let's take a look at number 11. So number 11. So I have log base 4 of 100, and I want to find 2 consecutive integers where the answer would be in between. So I would just start with like 4 squared is 16, so that's squared is too small. And then 4 cubed is 4 times 4 times 4, which is 64, still too small. And then 4 to the 4th, so 4 times 4 times 4 times 4 is 256, and that's too big. So I'm somewhere in between cubing it and raising it to a power of 4. So that means my exponents would be between 3 and 4. So between 3 and 4. Okay, and then let's take a look at graphing. So let's do number 13 for graphing. So I would want to add 2 over to the other side. So that would be y plus 2. So my start, alphabetical order, opposite on both. So that would be positive 1 and then negative 2. And that just gives me my asymptote, right? Just my asymptote. So I'm going to go over 1 and then down 2. And then I'm going to just make a dotted line there to give my asymptote. And then my stretch is 3 because I have a base of 3, so my stretch is 3. So from here I'm going to go over 3 and up 1, and then just over 1. And so then my graph would look something like this. Okay, so remember the start is the asymptote, right? Not actually part of the graph. And so my vertical asymptote, what axis am I crossing? So I'm crossing the x-axis, and I'm crossing at 1. So x is equal to 1. My domain is left comma right, so the farthest left my graph can go is to the asymptote, which is at 1. And then it goes forever to the right because of the arrow, so that would be to positive infinity. And it would be a parentheses on the infinity, but also on the 1 because the 1 is really the asymptote, not actually part of the graph. And then for my range, so bottom comma top, so it goes down forever, so down forever, so that would be negative infinity, and then up. So even though it doesn't look like it, this is headed up forever, very slowly, but it is headed up forever. So that would be to positive infinity. Okay. And then let's take a look at finding the x and the y intercepts. So let's do number 17. So to find the x-intercepts and the y-intercepts, I'm going to let x equal 0, but I'm also going to let y equal 0, right? That would find me my intercepts. So I'm going to go ahead and replace x with 0. Oops, actually need to do that. Okay, so let's replace x with 0. And so 0 minus 4 is negative 4. And so this is a no solution, right? Because I can't come up with a power on 2 that would make it negative. So then this would be no solution here. So that means when x is equal to 0, I can't find a y value. So then there's going to be no y-intercept. Right? Because I can't solve for y. So if I can't solve for y, there will be no y-intercept. So now I'm going to do the same thing again, but I'm going to let y equal 0. So I'm going to turn f of x into 0. And then isolate the x. So I'm going to add 3 to both sides. And then I want to get rid of the log base 2. So to get rid of the log base 2, I'm going to exponentiate it to a power of 2. So this is going to be 2 to the power of 3, and then 2 to the power of log base 2 of x minus 4. So the 2 log 2 cancels, and then 2 to the third is 2 times 2 times 2, which is 8. And then add 4. So x is equal to 12 when y was 0, so that's my x-intercept. So I have an x-intercept at 12, 0. Okay. And then let's take a look at number 18. So finding the rate of change. So in order to find the rate of change, I want to substitute in my numbers here, right? So I have negative 8 and 18. So we're going to let x equal negative 8. And then x equals 18. So I'm going to replace x. So negative 8 plus 9 is positive 1. So what power on 3 will make 1, right? So 3 to what power will make 1, and that's 0. So this is all going to be 0. And then minus 1, and 0 minus 1 is negative 1. So that ordered pair is negative 8, negative 1, right? Because I replaced x with negative 8, and then my answer was negative 1. So that's my ordered pair. And then I have to do the same thing for 18. So I'm going to replace x with 18. So that will be 27, and then I'm going to group that so I don't think to subtract 1. And so what power on 3 is needed to make 27? So what power on 3 is needed to make 27? That would be 3 to the third. And then 3 minus 1 is 2. So then my ordered pair is 18 because I used 18, and then my result was 2. So now that we have the ordered pairs, now we just find the rate of change, and that's when we're subtracting our y values over our x values. So our average rate of change, so I'm just going to do negative 1 minus 2, and then over negative 8 minus 18. So that would be negative 3 over negative 26, and then the negatives cancel, so just 3 over 26. Okay. All right, and then let's do one more here. So let's take a look at number 19. So when we expand, that means we want to make sure that we assign a natural log to each of my terms here. So the natural log needs to assign to the e to the third, the y squared, and the root x. So I'm going to do that. So that'll be natural log of e to the third, natural log of y squared, and then finally the natural log of root x, right? So each one of those got a natural log, and I want to always write them linear, right? No more stacked. And then I need to figure out how do I separate them. And so the different properties are going to tell me how to do that. So I was multiplying these two values together. So that means I'm going to separate to addition, right? So I was multiplying, I separate to addition. And then here I was dividing, and whenever we're dividing, we separate by subtracting. And then now I want to do my power rule. So my power rule is bring down the powers. So I'm going to bring down the powers, make them coefficients. So that will really be 3 natural log of e. And then bring down the 2. So that'll turn into 2 natural log of y. And then finally bring down the square root as a power as well, right? So the square root, remember, is a 1/2 power. So that means I'm going to rewrite the square root as a 1/2 power and then move it to the front as a coefficient as well. And then I could do one more thing here. This is the piece that we usually forget, but if I look, remember that the natural log of e, so remember that's a subscript of e, right? So I can actually simplify that. So e to what power will give me e, and that's just 1. So e to the first is e. So that means this will turn into 1, so I'll have 3 times 1, which is just 3. And then I can't do anything else, so then the rest will stay the same. Okay, and so for our log unit, I think that was it, but I thought we had one more page. Nope, okay, I guess not, but let me double check one more just to be sure. So there was another page, but I have somehow misplaced it. So that will just have to add on to a separate video, and I will figure out how to make that happen. Okay.